This is an example of angular and linear velocity of an object rotating around the Earth in this case. So here we have a satellite that is 8 miles above the Earth. It completes one rotation every 6 hours. And given that the radius of the Earth is 3,961 miles, we want to find the velocity of the satellite. But to find the velocity of the satellite, we first have to kind of deal with the angular velocity. We also have to kind of deal with the radius because that's not the entire radius. We also have to account for the 8 miles. So the radius of the Earth from the center to the edge, that's going to be the 3,961 miles. But then we also have to deal with the satellite's height off the surface of the Earth, which is another 8 miles. So we're going to need to add those two numbers together to come up with the full radius. So we're going to have the radius is equal to the 3,961 plus the 8 for a grand total of 3,969 miles of motion above the Earth, above the center of the Earth. Alright, the next thing to deal with is this completes one rotation every 6 hours. So that's one rotation divided by 6 hours. And we need to convert this into radians. So radians, every rotation it's going to do 2 pi radians. So we're going to multiply this, and we're going to get finally, per rotation, that way the rotations cancel out. So we're going to get 2 pi over 6 every single hour, radians per hour. This reduces, of course, to pi over 3 per hour. And we're going to call this omega. It's a fancy W. Alright, so omega is the angular velocity of the satellite. It finishes 60 degrees per hour if you want to change it into degrees. So the rest of it is the velocity formula, and the velocity formula in relations to omega is velocity equals omega times r. So here we're going to get the velocity is equal to omega, which is pi over 3 per hour. I'm just not going to write that part, times the radius, which is 3,969 miles. So when we're all done with this, we're going to have a miles on the top and an hour on the bottom, which will be, miles per hour. So this is equal to, well, actually I should say approximated by. So the satellite is traveling at about 4,156 miles per hour. Now, this is not taking into account, it's not over one point on the Earth, because you have to also remember the Earth is revolving, unless this is a north-south pole motion. So I'm just kind of ignoring that the Earth is revolving at all, and I'm just curious about the speed that the satellite is traveling around the Earth. That's it.